Okay, so in this video, we're going to compute a volume by adding up cross-sectional areas. So the question is to compute the volume of the solid, whose base is this region R, so it's bounded by y equals 4 minus x on the x-axis, and whose cross-sections perpendicular to the x-axis are squares. So it's a solid that's coming out of the board. If I take a cross-section this way, perpendicular to the x-axis, the cross-section is a square. So the volume of this region is going to be given by the integral. So if we know the cross-sections perpendicular to the x-axis, what we're going to do to find the volume is we're going to add up all of those cross-sections. So x is going to go between -2 and 2, and we're going to integrate with respect to x. And now what are we going to integrate? Well, we're adding up the areas of these cross-sections. So each cross-section, if I fix an x like this, here, then the cross-section coming out of the board is a square. So that means that this is one of its side lengths, and all the other side lengths are the same because it's a square. So the cross-section is a square, and the side length is this length. So fixing an x, the side length is given by the height of the function. So actually the side length is given by y, which equals 4 minus x squared. So the area here is the side length squared, right? So 4 minus x squared squared. So the volume then is when we add up all of those cross-sectional areas. So the volume is the integral from -2 to 2, 4 minus x squared squared. And the rest of the problem is just computation, so we can do it. Integral -2 to 2. I'm going to expand 16 minus 8x squared plus x to the 4th. And we know the antiderivative, 16x minus 8 thirds x cubed plus x to the 5th over 5, evaluated from -2 to 2. And this is equal to 16 times 2 minus 8 thirds times 2 cubed plus 2 to the 5th over 5. And actually, if you notice, so this is what happened when I plugged in 2 to this expression, and now I can subtract and plug in -2. Or if you notice that this is an even function, we can recall that I can just multiply this whole thing by 2. So either or.